Test 1 through 90 review. 20 questions here. Question number 1. A rectangular frame is divided by diagonal edges as shown below. If PI is 17 inches long, what is the length of QR? All right, so a rectangle is also a what? You know, parallelogram, right? So QR is a diagonal. What do I know about the diagonals of a parallelogram? No, not necessarily. They bisect each other. Okay? Now, because it's a rectangle, you're right, their diagonals are congruent, but they bisect each other here. The reason that we don't say that they're necessarily equal is because in a rhombus they're not equal, and a rhombus is a parallelogram. Does that make sense? So in a rectangle, the diagonals of a rectangle are both congruent and they bisect, which means that I know that IS is also 17, if that'll let me write on it. Okay? All right, and because all of these are congruent, then RI is 17 and IQ is 17, which means QR is what? (34 inches). Okay? Should be a pretty easy question for us to solve, correct? Yep. Great. All right, number 2. A swimming pool is in the shape of a cylinder with a height of 7 feet and a radius of 18 feet. How many cubic feet of water can the swimming pool hold? We want to use 3.14 for pi. We need to know what type of formula are we going to use? Are we using surface area, lateral area, volume? What are we using? What are we trying to find? Volume, okay? Specifically the volume of a what? Cylinder. All right, how do I find the volume of a cylinder? Pi r squared times height. Very good, Nick. Okay, pi r squared height. What are we going to use for pi? So volume equals 3.14. What's my radius? What's that? 18 is the radius. Okay, 18 squared, and the height is 7. All right, you guys have your calculators there. 3.14 times 18 squared times 7. Okay, and they don't say how many cubic feet, but it doesn't tell me where to estimate it out yet, or out at 7,121.52, and my unit is feet, okay, but it's volume, so it's going to be cubed. All right, what's the answer at the bottom say? Are we close? Are we there? Exact same? Takes it out to 2 decimal places. All right. So hopefully the big deal that you want to know here, because the numbers will be different on the test, is you need to know that formula right there. Okay? All right, number 3. We want to find the height in centimeters of a square pyramid that has a volume of 114 1/3 centimeters cubed and a base edge length equal to the height. Interesting. Okay. So square pyramid. Okay, something like this. Okay, and we want to find the height. Right? Find the height. Okay. Anything interesting about the height? I'm thinking specifically tick marks. Okay, so let's start off with the base. What kind of base do we have on this pyramid? Square. So what do I know? Can I put in tick marks anywhere in terms of the base? Yeah, like all around it, right? All these sides are equal to each other, correct? Okay, is anything else equal to any of that? Read the question. I need like Jeopardy music on cue. That's what I need. What's that? What is? The height is. All right, so this green line right there is equal to the lengths of each of these sides, okay? Now, we know what volume of the pyramid equals, but before we begin with that, what is the formula for the volume of a pyramid? We only have 20 questions, so I can wait around all day. The volume big B times h divided by 3, right? What does that big B stand for? What? Perimeter of the base. Nope. Area of the base. Area of the base. Okay, so what we have, all right, so let's say that we don't know, they don't tell me what the length is, right? So let's say, for instance, let's say that that's x, correct? Then that means that this is x. And what else is x? The height is x, okay? So let's kind of throw all that in together up here. What would the area be of that base? What's that? What's the area of this base based upon what I've written? X squared. All right, so x squared. And what is the height? X divided by 3. Can I simplify x squared times x? What is that? X cubed. Okay, so we could rewrite that as x cubed over 3. Can you follow me so far? Okay, but they told me what the volume equaled, correct? What did the volume equal? 114 and 1/3 is equal to x cubed over 3. Now, we could write this a little bit differently. We could rewrite that, if we wanted to, as 1/3 times x cubed, right? Now, could I solve for x? How? Divide by 1/3. Can I divide by a fraction? Multiply by what? Which is? Okay, 3 over 1, multiply by 3 over 1. Let's kind of leave that there. So what we need to do is we need to take 114 and 1/3 and multiply it by 3. Okay? Now, 1/3, we can't, in terms of writing 1/3 in our calculator, let's check this. Can I just do this? Can I write, let's clear that out. All right, so 114.33333 times 3. Will that work? Will that work? Is that the same as 1/3? No, it's not. Okay, we want to be as exact as we possibly can, which means I'm going to do this. I'm going to do 114 plus 1 divided by 3, okay, times 3. Gives me a solid 343. Now, the other way that you could do this is you could take 3 times 114 plus 1, right, and get that as an improper fraction first, right? So let's just see how that works. 114 times 3 plus 1, okay, comes out to 343, okay. So what that gives you is that's actually giving you what? 343 over 14, right? Or wait, sorry, 100 or 343 over 3, right? 343 over 3. So we would take 343 divided by 3 times 3. All right, we get 343 because the 3's cancel out. All right, so we get 343. That's not the end of my answer, though. Okay? Because what we're getting there, let's see if I can move some of this around. What we're saying is that 343 equals x cubed. I don't want x cubed. I want just x because x also represents my height. So what do I need to do with 343? Square root it, somebody says. Is that correct? No, unfortunately it's not, because we're not dealing with 343 equals x squared. We want to cube root 343 and x cubed. What's the cube root of 343? 7. Great. So 7 equals x. X represents my height. Okay. It also represents each length of the sides of the square base. Okay? All right. So 7. Is that the answer at the bottom of the page? Perfect. Okay. So that requires some depth of knowledge there. All right. Let's look at number 4. Okay. In the diagram, circle A is tangent to circle C, which means these two circles touch at exactly one spot. BD is tangent to circle A, which means it touches it at exactly one spot. The radius of circle A is 7 meters. The radius of circle C is 4 meters. We want to find the area of our triangle. Okay? All right. We see this question on a test. What's the first thing you're going to do? Cue Jeopardy music. How do we solve this? Plug in what you know. Great. That's a great place to start. What do we know? The radius of what? Okay, the radius of circle C is 4 meters. Can you tell me where to put 4 at? You want to come up here and point it out? I mean, even if you just put a dot, I could fill in the rest. Tell me where to put 4's at. Okay. All right. Is that the only radius on that circle? Okay, perfect. Okay. So he's absolutely right. The diameter of circle C, it would be what then? Would be 8. Okay. What else do we know? Caleb. The radius of circle A is 7. Can you show me where to put that at? Okay. Is that the only place it can go? Okay. Okay, so that's the information that we know so far. There's one important thing that's missing, okay, because if we want to find the area of a triangle, what's that formula? Or base times height divided by 2, correct? Okay. Still something important, and that is that BD is tangent to circle A. That's going to tell me something about the relationship between BD and AB. Segment BD and AB. Does anybody know anything about those? A tangent line and a radius meet at what kind of angle? 90 degrees. Okay, which means I can put 90 degrees right there. Okay, that's important because I think the mistake that a lot of you would make if you didn't have that is that you would take, I'm going to take 7, I'm going to add 8 to that, I'm going to get 15. 7 times 15 is what? We can probably find that out pretty quickly. What's 7 times 15? 105. 105 divided by 2. And you're going to write 52.5 as your area, right? Because I've got my base, I've got my height, right? Multiply those, divide by 2. Would we be correct? No, because AD is not the height. What is AD? The hypotenuse, right? What do I need to find? I need to find BD. I've got to solve that. Okay? Now, we can say that, we can either count this BA as the base, right? We could say 7, right? We can put 2, but we still have to find BD. How am I going to find BD, Nick? Okay, go ahead. Pythagorean theorem, he says.
7 squared, 4 squared.
Plus 4 squared? 7 squared plus 4 squared? All right. Do you see this side right here? We said earlier that this was the hypotenuse, right? So is that going to go on the left side of this equation or on the right side? The right. And so is the hypotenuse, is it 4? Is it 7? What is it? 8 plus 7, so it's what? 15. So just, 15 squared, okay. And then you said b squared goes here. Okay, so help me fill out the rest of this. Okay, all right, 49 plus b squared, 225. Subtract 49 from both sides, he says. Square root 176, 13.3. Okay, so b, he says, equals 13.3. Okay, so we're going to take 7, we're going to multiply it by 13.3, and then divide that by 2. $46.55, but let's look back at the question here for a second. Do I want 46.55 or do I want to do something else there? Look at the very end of it. Find the area of triangle ABD to the nearest what? So 47 meters squared. What's the answer? 46? So let's see. We might have rounded incorrectly someplace. Let's double check our math here so we don't make a mistake tomorrow. Okay, so we got our 15, we got our 7. Okay, 225. Let's double check our 15 squared. 225 minus 49 does come out to 176. Square root of 176. All right, you rounded it up to 13.3. Let's leave that as, in fact, let's just take it to like, and I'm not necessarily against you on that. In fact, if this is a fill-in question, I'm probably going to give you 47 at that point, okay? It's going to be pretty close. I'm going to take 7 times, let's try 13.27. That's 92.89 divided by 2. I get 46.445. Now, even there, I would probably agree with you, Mick. I would probably still wind up putting 47 because the 5 rounds up the 4. Now 5 rounds up the other 4 is a 5. All right, that 5 rounds up the whole thing. But because they're just looking at 46.4, then you would round it down to 46. Okay? So, again, I wouldn't look at that as an error on your part. It's just a rounding issue. Anytime now. There we go. All right. What are we ready for? Number 5. Where is number 5? All right. Draw a rectangular prism in 2-point perspective in which the vanishing points are above the prism. I'm going to just, okay. My vanishing points, if I'm looking, basically it's something like, this gets tricky. And I don't know if we'll see a question like this. Vanishing points should be up here. I want to say that they'll cross and then we'll wind up with, I don't know, something, whatever. Let's look down and see what the question should actually look like on this. Yeah, right there. So that's what they're looking for. I will look through the test. I don't want there to be a drawing question on the test. So if there is one, I'm very likely to take it out and replace it with something else. So be prepared for that. Okay? All right. So we didn't spend a lot of time there. Let's go back up to number 6. Okay? Find the values of x and y in the diagram below. Give your answer in simplified radical form. All right, notice it's a 30, 60, 90 triangle. I think that you've seen a question very similar to this, if not this exact question on your last test, right? Maybe I'm thinking of Algebra 2, but I think on your last geometry test. All right, notice that 30 across from 30 is 12. All right, so what should my hypotenuse be? Nope. 24. All right, so we need to go back to, you're in the right ballpark, minor. Okay, so if what's opposite of 30 is x, then the hypotenuse is 2x, and the side opposite of 60 is x radical 3. Okay, so we always go from the 30 first. Okay, so if what's opposite of 30 is 12, then the easiest one for my hypotenuse to be is double that, right? So what is x in this case? 12 radical 3, right? I think you just had them flip-flopped, okay? So definitely want to have that down, okay? Are we getting a little bit better with the 30, 60, 90s? Hopefully. Okay, they might throw in a 45, 45, 90, which makes radical 2, correct? Okay. All right. 7. Hopefully we'll get at least half of these covered. Line M is tangent to circle C at point T. Line N passes through C, the center of circle C. Line M and N intersect at point S. Line N contains CR, a radius of circle C. So they say sketch this. Sketch lines N and M, mark CR and S and T on your sketch. All right, so let's move around here so we have some room to draw. Okay, so what's the first thing that you want to draw? A circle. Okay. So work for you? It's not too bad. All right, line M is tangent to circle C. Okay, so we need to draw a line. Anybody want to draw a line that's going to be tangent to this circle? What do we know about a tangent line? Okay, describe a tangent line to me and then I'll draw it. Touches the outer part of a circle. Does it run along it? Does it run through it? Or does it just touch it? Just touches it. Okay, so I'm going to draw that line right there. Does that look pretty close to a tangent line? With that kind of what you're describing? Okay, so all right, there's circle C. In fact, because that's circle C, I need to put that there. Let's see. What do we label this red line here? What do we call that line? M. Okay. It says line N passes through C, the center of C. Lines M and N intersect at point S. So what do I need to draw line N. What do we know about line N? It goes, what is it? It goes through the circle, not only through the circle, but through the center of the circle, right? All right, so, and we know it's going to intersect. Okay, so we have some stuff there. Let's see, lines M and N intersect at point S. Where do I want to put point S at? Where what intersects? M and N. So we need to describe that as N. We're going to call that S, correct? Okay? All right, so we've got C, we've got S. Line N contains CR, a radius of C. Okay? Radius of circle C. Okay? So we can put R somewhere. Where would we put R? So I could put R there. Would that be a radius? Okay? So we've got that stuff. Have we fulfilled our obligation to A here? Sketch circle C, lines N and M, mark C, R, S, and T on your sketch. Have we missed something? Missed T. Okay. What do we know about T? It's where N and, let me see it again. I guess I'm missing it. Oh, let's see. Line M is tangent. Okay, so we need this. Let's use a different color here. We would call that T, correct? Okay, good. All right, so we've got it. Let's see. B, if measure angle CST is 36 degrees, determine the measure of angle TCS. So let's come in here. We should know this angle, CST, is 36 degrees. We want to determine the angle of TCS. So we need a new line. That line is going to come to there, and we're going to look for this guy. Okay? All right, do we have enough information? We know that this is 36. What have I made here? A what? A triangle? Yeah, we made a triangle. Okay, so we're triangle and angles. What number do we typically deal with when we're talking about triangles and angles? 180. But I only know that I only know 1 degree. Do I know anything else? What is TC? What's another name for TC? What? No, because a chord goes all the way through. A radius. All right, what do I know about a radius and a tangent line? Right, even though it doesn't look like it, but that's drawing error more than anything, right? TC and this line, of course you can see that the biggest problem there is that my line kind of curves, right? That should be 90 degrees. So now do I know how I can find my angle? 90 minus 36, 54. Okay? 90 minus 36, I'm told is 54 degrees. So 54 should go there. Explain how you arrived at your answer in part B. All right, I'm not asking you to do that. It says, what is measure angle of arc, RT? So we're going to look for right here, correct? RT. How do I find that? Well, what's the book say? Does it say 180 degrees? Or what's the answer? 54 degrees? Okay. So what we're looking for is we need to find the angle from here to here. I didn't do a good job of really describing that, but we're looking for that angle right there. Okay? .54 degrees, this means well, we're probably going to have to stop right there. We'll come back to you guys. I'll probably finish this up with the other class. Okay, we'll try to get a bunch of this done. Ready for your test tomorrow. Okay, how do we find arc RT? 180 minus 54. Okay, so what you're saying is find this angle right here, right? Okay, we can do that. What's 180 minus 54? 126. So I would probably agree in saying that, and this is our central angle, correct? which means the intercepted arc of that central angle should also be 126 degrees. What does the answer come out to?
That's at the bottom, isn't it?
Yeah, it'll be at the bottom.
Number 7?
7D. What's it? It says 54 degrees. The only thing that I can determine is the problem here is that there wasn't, if we go back up to look at statement 7, it says line N contains CR, a radius, correct, of C. The problem is that it can, well, actually, no, I mean, you very well could be right on that. The difference is that I think what they ultimately did is they put R there, in which case this is 54 degrees, which means this arc would be 54 degrees. Does that make sense? So I think that the failure of not getting 54 is from them not being specific about where that R would be on line N. Because if it was over here, which it very well could be, right, it would make that 126 degrees instead of 54 degrees. So, yeah, question.
I don't really notice the second B that's up there.
The second.
A, B, C, B, D, E.
Keep reading. Explain how you arrived at your answer in part.
B. Oh, I just saw the B and the dot, and I was like,
Yeah, A, B, C, B, D, E. Yeah, no. Yeah, at least I am recording, so at least everybody knows.
yeah, that. Dominic Dabney.
It's not
Can't
one.
read.
So on the test, should it be either or?
I would probably take a really close look at that and do it either or. Right? It should be. You couldn't get anything else besides 54 or 126. What I would say is if by chance this came up on a test, which it probably won't because it's not really a multiple choice question, then what you would need is a picture, right? You would need your illustration in your box representing that, and I would take a close look at it. So we're going to say 54 or 126 degrees.
So that's the question that's not going to be on the test.
No. On the test should be a question that's going to be based upon this. It won't be that question, obviously, because it'll be probably a multiple choice question.
Right.
But the one that I'm removing is one that says draw a rectangle in 2-point perspective if the vanishing points are above the rectangle. I'm not going to have you do that. Does that make sense?
Okay, so it's basically this one and the other one, right? Never mind.
All right. So if CR is 25 inches, okay, which makes it the radius, okay, 25 inches, find the arc length of RT, okay? Let's go ahead and base that on this side since we want it to be able to match up. Arc length is using what formula? How do we find arc length? Arc length, not area of a sector. 2 pi r. All right, so we're going to use 2 pi what? 25. What's my measure? 54 over 360. We're going to leave everything in terms of pi, so 2 times 25 is 50. So we're going to take 50 times 54 divided by 360. 7.5. All right, so 7.5 pi, right? Let's see, inches squared. Is that the answer at the bottom of the page? Very good. All right. See, and I was recording. I did hit record, right? Hopefully. I did that. I remember doing that. Sure. On E, find, where does it, what do you mean it says find it twice?
Oh, okay, the length and the, okay.
Okay. All right. Number 8.
Yeah, that's good.
Number 8. Find find QU. We want to find this length right here. Proportions, right? Okay. So let's set up a proportion. This one, I see people miss these questions all the time because they flip-flop things. Okay. All right, so there's two ways to do this. You can do QT. Actually, there's probably about 4 different ways to do this. QT over QU, okay, equals, okay, if I'm going to do QT over QU, then I'm going to do TR over US. Okay? Does that make sense? What I cannot do, okay, let me just make sure that this is clear. I cannot start off with QT over QU and then jump to US over TR. Okay? Do we get that? Now, one other possibility is I can do QT over TR. Okay, I can do this length over this length. It's proportional to QU over US. Okay, but again, if I'm going to do QT over TR, I can't do US over QU. Okay, you get where I'm coming from? All right, now let's set up, let's just use the one that we've got here. QT is 12 over 5. Okay. QU we don't know. US is 4. Okay, so cross multiply and divide. We want 48 divided by 5. What does that come out to? What's that? 9.6? Okay. What was the answer at the bottom? 9 and, was it come out as 9 2/3 or what? 9 3/5 because 0.6 over 10, so 9 3/5. Okay, because 6/10 does come out to 3/5, I would accept either of those answers on the test if it was a matter of you had to type it in. Okay, so 9.6 or 9 3/5. Probably easier for you to type 9.6. Okay, 9. Find a measure of angle ABC. Given below, given that BC is tangent. Okay, this one is really simple, but again, people are still forgetting how to do these. If I just want to find ABC based upon the information I'm given, what am I going to do? Divide what by 2? 217 divided by 2. Okay, what is that? 38.5? 108.5. Okay, 108.5. Okay, we feel like we understand that. Not a whole lot of work to show. We just want to be careful with that. Now, question, yes?
If there's like 2 numbers, how do you know when to add? How do you know when to subtract? Like whenever you're trying to find the average, like not the average, but
You're talking about a different question form. So the question that you're asking about is a situation that looks like this, where you're given this, and you're given something that looks like this, right? Okay, so in this situation, we're going to call this the major arc here. This is the minor arc here, okay? And, let's just call this X, for instance, okay? You're going to do major minus minor divided by 2. It's going to be equal to X. Now, you may have X and be asked to find the minor. Okay, you may have X in the minor and be asked to find the major. All you got to do is fill in. Okay, does that make sense?
okay, but then when do you find the average? Like when do you?
You find the average here, and I think she's absolutely right, but you're going to find the average given a situation where you're looking, you have a number here and a number here, and you're looking for that. Okay? You add those two up and divide by 2 to find our angle in the middle. Okay? So yeah, they're very similar and very easy to get confused. So this is a good question to ask. Okay? Number 10. Use the apothem and perimeter to find the area of a regular hexagon with side length 4 feet. What do we need to do to begin with? Draw a hexagon. Okay. How many sides does a hexagon have?
6.
5, 4, no, it's 6. Okay, so that works, right? Okay. All right, I've drawn a hexagon. What happens after that?
The middle, bottom middle.
So from the center of the hexagon, okay, to a vertex or a side.
Sorry.
Okay, so from here, okay, I've drawn that line. What else?
Make a right triangle out of the apothem.
Okay, so you mean that, right? Correct?
Put it 4 out of the like leg right here.
So 4?
No. That's one.
What? You want to come up here?
No. Put a 4 as the vertical leg. This one, straight.
Right here. You want me to call that 4?
It says 4.
It does say 4. Does say 4. Does say 4. Just doesn't mean therefore.
Never mind. It's the side.
Yeah. Maybe that like original place where I put it.
Listen, I'm blind.
Listen, I'm blind.
That's my excuse.
All right. All right. Where do I go from here? Divide by 2, so that's going to give me that length there, correct? Okay. Next.
Like, if you completed the other side, it'd be 60, and then you divide 60 by 2, and you get 30 on the top and then 60 at the bottom. Like for your angles.
Are you 100% positive that it's going to be a 30, 60, 90? How do I know for sure? Okay, I think what you're trying to do is you're trying to find that angle right there, correct? Okay, so let's think about this. If we had to think about it, you know, if I didn't know for sure and I had to figure it out, right? How many degrees are in the inside of that hexagon? 360 degrees. I want to find out how many are inside this acute angle, the pointed part of that triangle. How do I find that? Divide by what?
The number of sides.
Number of sides. Okay, so you're saying 360 divided by what? And then what? Divide by 2 again. So could I just take 360 divided by 12? And I'm going to get 30. So in this case, yes, 30, which means 60 and 90, right? Okay, that works out with every hexagon. But your question on your test might ask you to find the area of a heptagon, right? In which case I would take 360 and divide it by 14, right, to find that angle, which is going to be a little bit more challenging. All right, we're going to look for that guy right there, all right, which we should already know, right? If opposite of 30 is 2, then what is my apothem? 2 radical 3, all right? So x equals 2 radical 3. Now, let's say that you couldn't remember your 30, 60, 90 ratios. Could we solve it a different way? Yeah. All right. For instance, from here is opposite over adjacent, right? So tangent. Okay. Let's see. Sorry. Thinking about a couple different things at the wrong time. Tangent 30 degrees equals 2 over x. So I would ultimately wind up with 2 divided by tangent 30, right, which is going to give me a complex number because it's 2 radical 3 is going to be irrational. But in any case, we do know that we do have 2 radical 3, and our formula for finding area, okay, is apothem, in our case 2 radical 3, times perimeter. Okay, well, what's the perimeter of my hexagon that has a side length of 4? 24? 24. Okay, 6 times 4 is 24. Okay. Let's see. Ultimately, what I would say that you could do, 2 radical 3 times 24 is going to be 48. Radical 3 divided by 2 is 24. Radical 3, I don't know how specific they want you to be, but this is going to be an exact answer. What is the answer at the bottom? Okay, so exactly that then. Okay? So 24 radical 3 feet squared.
Man, things are super creepy.
I know. You would think that they improved the floor, that the floors would stop creaking. And when they do, they smell bad. I know, it's wild.
Someone buried under.
All right, number 11. Give the sine, cosine, and tangent of angle E in a triangle below. Before I can find, let's do this, of angle E. So let's just do that there. I can find tangent, but I can't find sine or cosine without what? The hypotenuse. Now, the nice thing about this is that it's based upon a Pythagorean triple, right? A Pythagorean triple is 3, 4, 5, right? Now look at this. Okay, if I divide everything by 2, do I still get 3, 4, 5? All right, 6 divided by 2 is 3. 8 divided by 2 is 4. All right, so what's 5 times 2? 10. So I should get 10 here. Now, if you couldn't remember that, that's fine, because we could do 6 squared plus 8 squared equals c squared. We get 36 plus 64 is 100, and the square root of 100 is 10. Right? We're going to use the Pythagorean theorem to find that side. So on sine, what is sine? Sine is something over something, right? Opposite over hypotenuse. What is opposite of angle E? 8. What is hypotenuse? 10. What's that reduced to? 4/5. All right. Cosine is what over what? What is adjacent in this case? What is hypotenuse? 10. What does that reduce to? 3/5. All right. Tangent. Opposite over adjacent. Huh? Sine over cosine. Yes, that is true. You could do 4/5 over 3/5 and then multiply by the reciprocals and get those answers. You'd wind up with like 20 over 15 and reduce? Right? It's a little bit easier than that because we're just going to do 8 over 6, right?
Thank you, though, Dylan.
8 over 6, which is 4/3. All right, can we do that? Yes, we can. Like Bob the Builder. All right, number 12. The following 5 points form pentagon MNPQR. It's going to say graph the points, draw the pentagon, reflect pentagon across the x-axis. If I'm reflecting something across the x-axis, what is happening to the coordinates?
Bigger, negative.
Does everything?
X goes negative, right? What opposite?
Okay, if you're reflecting something across the x-axis, so let's say we have this position here. That means the new position is going to be here. So I'm going from 1, 1.
Oh, y goes negative.
Right, y goes negative. The x value stays the same, correct? So rather than me spending a lot of time drawing this and then reflecting it, what you need to remember is that whenever I reflect across the x-axis, the y flips values. If I flip across the y-axis, the x value changes sign. So what I get here is -3, -4, -5, -3, -4, -1, -2, -1, -1, -3. And then plot those points, and you've got the reflection. Does that make sense? Cool. Cool. let's see, 13. Identify whether the figure below has a line of symmetry. If it does, draw that line of symmetry. Billy, does that figure have line symmetry?
What number are we on?
13. Thank you for participating. All right. Can you come up and draw that line symmetry that it has? Yes, you do. He asked if he had to. Handing him the marker of destiny.
Just pretend like that's straight. Pretend like that's straight.
Keeping thoughts to myself, not saying things.
Shade.
No shade, no tea, but.
Okay. That answer is correct. All right.
He did so good the first time.
I'm trying so hard to have a filter. If triangle ABC has vertices 0, 2, negative 3, 2, and negative 2, 0, graph the triangle and its rotation 180 degrees counterclockwise about the origin. We don't really need to do that, but what I do want to know is, what are the new coordinates? What happens whenever I rotate something 180 degrees? What happens to the x and y values? They both, okay, so let's come back to our handy dandy graph here. If this is 1, 1, right? Where's 180 degrees from that? Right through here. It's going to go through the origin. I'm going to be at negative 1, negative 1. So what happens to the x and y coordinates whenever I rotate something 180 degrees? They both change signs. They don't flip locations. They just change. So what I'm going to get is 0, negative 2, because 0 doesn't have a negative. I'm going to get 3, negative 2, right? And 2, negative 0. Kidding, just 0. All right, number 15. Find the surface area of a sphere with a 12-foot radius in terms of pi. I feel like calling on Billy again.
You should. You can pretend he's straight.
What is the formula for finding the volume of a sphere? 4/3 pi
R. Cube.
4/3 pi r cubed. We want to find the surface area of a sphere with a 12-foot radius in terms of pi. 4/3 pi 12 cubed. Okay. What is 12 to the third times 4 divided by 3?
2,305.
2,304 pi feet cubed, cubic feet. Is that the answer?
No.
Oh, it's not an answer. Is 2,304 just 12 cubed? It's 4 pi r squared. Oh, you're right. I'll tell you, because I said volume. You gave me the volume based upon the question, but that's not the formula we need to solve this question. We need 4 pi r squared. 4 pi 12 squared. What's 144 times 4?
576.
576 pi feet squared. But we did find the volume also, so overachievers. Kudos. Huh?
Let's not blame everything on Dom.
I
Tom's fault.
didn't. No, it was my fault
Yours too.
because I said volume.
He goes back and
In the diagram below, find theta to the nearest degree. Which trig function would we use Brady Sayer.
We'd be using a squared plus b squared plus c squared.
That would find xz, but we are looking for the degree of angle theta. Would you like to phone a friend?
Yes.
Which friend would you like to phone?
Gone.
Ring, ring. Hello?
Wait, but isn't he supposed to say hello?
But he wasn't participating. So. The phone goes green, green. I pink it up and say yellow.
61 degrees.
Okay, tell me how you found it.
Sin.
Sin. No. Sorry, the I is long. It's
Say
sine.
that we did that. You did not look at that.
All right. So sine. Why did you use sine?
Because of the thing that I cannot pronounce. The zero with a circle. The zero with a line.
Theta.
Theta.
Still can't say it.
Theta.
With a th. Can you say the?
The. Theta.
Theta.
Can you say they?
Theta?
Imagine saying hey, but with a lisp. Hey.
Say.
With a lisp. All right, so let me kind of help us out here. 7 is opposite of my angle. 8 is hypotenuse. Okay, sine is opposite over hypotenuse. So we're going to use inverse sine because that's what we use to find an angle. Then we're going to put those things in our ratio, which is 7 over 8. Inverse sine 7 over 8 comes out to
61 degrees. 61.
61 degrees. Is that the answer? Is it here? 61 degrees. All right, 17. We are getting so close to the end. In the diagram below, apply a dilation of AB using a scale factor of 2 and center C. I'm going to help you out with this one too. Okay. What we want to do with this is we're going to say if we had a ruler, this would be a little bit easier to do. But
We don't.
our okay. We're going to find whatever the distance from C to B is, and we're going to continue that distance on out. Okay, that same exact distance, so probably right about in there. And this would be, B prime. We would do the same thing from A or from C to A, and then again. Okay, those need to be the same distance. Okay, and we would find that, and then you could measure, if you wanted to. But ultimately, what that's going to do is it's going to force AB to be the mid-segment of a mid-segment triangle, where the side opposite of AB is double the length of AB. So it's going to be 12. 12. All right. What do you mean? What, like, is it going to ask if it's A prime, B prime, or what?
Well, it says,
What was the question?
since AB was 6 and it was enlarged by a factor of 2, A prime is
Okay, so it was asking how long it is. Didn't understand the. Okay. Okay. In circle M, chords Q, R, S, T intersect at U. Determine if T. Hey. You want to go
Going where?
downstairs? You can make your way downtown and you walk real fast. Okay. All right. Circle M. Okay. Circle M. Chords Q, R, S, T intersect at U. Determine T, U if Q, U is 6, R, U is 9, S, U is 7. So chords. Let's start with that. Okay. Shouldn't matter. This is going to be considered a chord. They don't give me any specifics like this QR is also diameter. Let's call it. I got to pause. All right. Let's see. We got QR and ST intersecting at U. So let's make sure that they intersect. ST and intersecting at U. Okay. Determine TU if QU is 6. Okay. So 6. RU. Oh. RU is 9, SU is 7. We want to find that guy right there. All right, so this is a pretty easy question, but it's not one that we've spent a lot of time doing. Okay, so basically what you run into on these, I don't know how many of you remember this, but the product of the segments is equal to each other. So what I'm saying here is 6 times 9 is equal to 7x. So we would find x by taking 6 times 9 divided by 7. 54 divided, or was that? Yeah, 54 divided by 7, right?
The answer is about 7.7142.
Well, thank you. I wasn't even asking. 7.71428574142.
Nicholas probably in the rapid calculator.
Thanks, Siri.
Imagine like a kid trying to like cheat off there and like
Just to hear it.
ow.
Yeah.
Like,
What if they're talking to themselves?
What is the answer at the bottom of the page?
It's 7 and 5 seconds.
7 and 5/7. So that's probably, yeah. I mean, I would probably take it as 54 divided by 7 equals x. Okay. Let's see. Solve the strictly linear inequality. 6x plus y is less than or equal to 4. We want to solve for y. Bill, you want to solve this one? Okay. And be quiet.
What am I solving for?
You're solving for y in question number 19.
Both those wires, what is it supposed to be for?
I'll help you out here. This is the y one. The other one is a 4. Subtract 6x, so we get y is less than or equal to what?
6x plus 4.
Close.
Negative.
Negative what? Okay. Is that the answer? Yes, it is. All right, last
It's a
question.
weird symbol.
What's the what?
It's a weird symbol for it.
Probably just doesn't, I'm guessing it's an error whenever I convert the document over to a rich text format. It probably doesn't do a good job with inequality symbols.
Okay.
All right, 20, reflect triangle QRS across line M and then translate it along V. With this, you should wind up with something that's going to look about like this and then move it up. You know,
You're right.
I don't know, whatever. Something that looks similar to that. We're not getting into exacts on that. So that is the review. It's only 20 questions, which means most of the questions on the test should be run fairly similar. What? Okay.
Are you going to go to